the session 2, which is about innovative coastal observing system. It will be a mix of in-presence and oral and online, sorry. And it's also a mix of a poster and oral presentation. So the poster are 5 minutes, so it's a short speech. So the first one is Pauline, online from Kenya Marine and Fishery Research Institute.
Hello all. Hope you can hear me.
Yes, very well. Please go.
Okay, this is Pauline Nyambura Mwangi. I'm a student at Chuka University. I'm pursuing Masters of Science in Environmental Science. Currently, I'm assessing the impact of shoreline change on the national marine environment at Gazi Bay, Kenya. And my supervisors are Dr. Joseph Maina at Chuka University, Dr. James Cairo at Kenya Marine and Fisheries Research Institute, and Dr. Jane Dongo from UNEP. So shoreline is a boundary between the land and the ocean, and it is influenced by both natural and human activities. And shoreline change affect the flora and fauna distribution and the composition along the coastal zones. And also shoreline change causes gain or loss of land. And for this study, I quantified the rate of shoreline change and the impact it has on the national marine environment. The broad objective was to understand the rate of shoreline change and its impact on coastal and marine environment in Kenya. And for specific objectives, I was to estimate the change in shoreline positions from 1990 to 2020 and identify the hotspot areas of change and the spatial temporal changes of the national marine environment. This is my study area where you have the two rivers, River Kidogoeni and River Mpumuzi. And this is my study area. We have two villages that are involved in Gazi Bay. We have the Gazi, we have Makongeni. And for this is the upper side of the bay and the south side of the bay. The upper side is protected from the waves by the Chale Peninsula and the Chale Island, whereas the southern western creek, this is the western creek, we have the eastern creek. This is more exposed to the waves, and hence we are experiencing a lot of shoreline change in this place. So I acquired the satellite data from 1990 to 2020 from the Landsat data. I pre-processed using the NV software, and then with the Landsat data, I digitized the shoreline positions, and then I extracted a baseline to help me to cast the transect at 50 meters apart, perpendicular to the ocean, and I was using the digital analysis system. And now with the shoreline positions, the baseline and the transect, I calculated the shoreline statistics, which include the endpoint rate, the weighted linear regression, net shoreline movement, and shoreline change envelope. Now using the linear regression rate, I predicted future shoreline positions for 2032 and 2042, and I used the Kalman-Filter model. To understand the changes in the national environment, I did a supervised and unsupervised classification. And these were the results for shoreline positions. I extracted 7 shoreline positions from 1990 to 2020. And we have 2020, 2015, 2012, 2005, 2001, 1984, and 1989 shoreline positions. And from the results, I found that where we have the red is where we are experiencing erosion. And mainly we had one area where we're experiencing erosion. And where we have the lead, here is called Mwakore landing site. There are human activities here. Here is another fish landing site called Mwamzagaza. It's a landing site. And right now we have another project on seaweed farming. Here we had, in 1990s, they were introduced artificial rocks to prevent shoreline change, and instead, the rate of erosion increased. And then we have the River Mau or River Mpumuzi. The southern side of the river were experiencing erosion. And this is the area that had the highest rate of erosion at a rate of more than negative 2.5. And for the accretion, I had allowed the 2.5 change of sediment accretion rate per year. Now, for shoreline prediction, I found that at these areas that we had erosion, there will be continuous change in shoreline position or landward movement of the shoreline. And this is the graph. And I found that at the river mouth, the southern side of the river mouth, we are still going to have the highest rate of erosion, followed by where we have the introduced artificial rocks in 1990s to prevent the shoreline, and now the another landing site here and another landing site, fishing landing site here. And here we are going to have the place will continue to have sediment depositions. So this is the graph from the shoreline change statistics. I found that in between 1989 and 1994, the shoreline was changing at a rate of negative 1.47. The rate increased between 1994 to 2001, and it went to negative 2.34. In between 2001 and 2005, the shoreline was almost stable. The rate of erosion increased between 2005 and 2012, and 2012 to 2015, the shoreline was not changing at, it was more of accretion. And between 2015 and 2020, the rate was more of erosion at negative 2.25. I found that in between 1994 and 2001, we had the El Nino of 1998, and this would be the cause of the increased rate of erosion here. And also in 2015, we had another El Nino. And for the decades, I found that in between 1989 and 2000, the rate of erosion was high, and then was the highest. In between 2000 and 2010, it was the shoreline was not changing a lot. It was changing at a negative 0.3. And for the last decade, 2010 to 2020, the rate of erosion increased. For the hotspot areas of shoreline change, I found like this. Here we have this is the accretion site, or where the sediment is being deposited, the upper side of the bay. And this ridge is growing toward the northern side of the bay. And comparing this the year 2001 and 2020, I found that all these mangroves by 2020 they were lost in between 2001 and 2020. And this was the result because of the sediment accretion or deposition. And also I found that there was reorganization of mangroves, whereby like here we don't have mangroves in 2001, but here we have mangroves. So there was reorganization of mangroves. As also this boundary was moving toward the northern side of the bay. Here, this is where we have the introduced artificial rocks, and they were introduced to prevent shoreline change, but instead the rate of erosion increased, and the impact was that there was a lot of loss of mangroves in the side of the ocean, and also there was landward. There was erosion, and this is the year 2020. This is the year 2021. This is the lower side or the southern side of the River Mkuruzi. The lower side, the southern side was this where we are having more of erosion in Gasbe, and this is the result. Comparing 2001 and 2020, this is where we are having the highest rate of erosion and loss of mangroves. And also we found that there is a formation of a sad pit as per now 2020, and there is also formation of sandy bars. There before the river was flowing direct to the ocean, but now it has formed a curve. So these are the rocks that were introduced. These are photographs. When I did the land-based or the land-use land cover change, I found that these are the mangroves. I found that like in this place, we have a loss of mangroves. If I compare 1989 and 2020, here it was mangroves, but now they have been lost. They have been washed away. Also, I found that there is increase in built-up areas, or indicating that there is an increase in population in Gasbe. And also when I checked the river, how it was flowing, I found that the river has changed. The river has changed. The way it is entering to the ocean. I'm trying to move to the next slide. My computer is not. I don't know what has happened. My slides are not moving.
Pauline, do you want to come to the conclusion? Maybe you can.
I don't know why my slides are not moving. So in conclusion, I found that both natural activities and the land-based activities have contributed to the increase in shoreline change in Gazi Bay. And where we had mangroves, it was observed that the rate of erosion was low compared to where we didn't have mangroves. So where we had mangroves, the mangroves acted as they break the waves, and hence the rate of shoreline change was slow. To conclude, my work was funded by Kenya Marine and Fisheries, Chuka University Alumni Group, and the Society of Wetlands. Thank you.
Thank you so much. Any question for Pauline? Yeah, I have one. Did you use also satellite data for this, or only transect in situ measurements?
I mainly used the Landsat data, and I went to ground truth. I went to the area just for ground truthing.
So maybe next step will be also to exploit more the satellite data, I guess.
Yeah.
Okay, thank you so much. I hope.
Okay, thank you.
So next presentation is a poster, so it will be a 5 minutes short speech online by Helen Kizenga from Institute of Marine Science, University of Dar es Salaam. Just a moment, Helen, are you online?
Yes, I'm online. And I can't share because Pauline is still sharing the screen, I think.
Pauline, can you close your sharing?
Okay.
Thank you. Right now, Helen?
Okay, okay.
Yes, it's coming up. Please,
okay, okay, you can see it, right?
Yes.
Okay, so my name is Helen Kizenga from the University of Dar es Salaam, as I've been introduced. And since I have a very short 5 minutes, I'll just go straight to the point. So our study mainly focused on identifying the links between the remotely sensed biophysical parameters and the mackerel fish catch. So we mainly aimed at trying to understand how we can use the remotely sensed data for small pelagic fishery in Tanzania. So this technology is widely known around the world, but in Tanzania, it is just starting. So we saw the need to try to understand first what are the linkages between the remotely sensed chlorophyll A, sea surface temperature to the mackerel fish catch, which is one of the priority fishery in Tanzania. So in doing so, we aimed at trying to help the fishers in using less resources during fishing and also during the management purposes. So in this study, we had a set of first of all, we conducted it in the Eastern Pemba Channel. So in Tanzania, we have 3 channels. We have the Pemba Channel, which is in the northern part, and we have the Zanzibar Channel, which is in the middle, and then we have the southern part, which is the Mafia Channel. So we conducted it in the Eastern Pemba Channel, and we used a set of 4 data sets where we have the remotely sensed data. We had chlorophyll A from the Ocean Color Climate Change Initiative, and then we have the sea surface temperature from MUR, and then we used we used model data, mixed layer data from the NEMO model, which we are trying to understand the physical processes that could be causing enhanced productivity in this region. And also we had a rare data set of mackerel fish catch, which we were able to get from the Department of Fisheries in Pemba. And then we did an interview with local fishers and other stakeholders in small pelagic fishery in Pemba to try to see what they understand about the seasonality and other aspects of fishery for the case of mackerel. So in our findings, we were able to see that on the seasonality basis, we were able to understand that the phytoplankton productivity or phytoplankton biomass in the Eastern Pemba Channel is higher during the southeast monsoon season, which is the we call it the cold season, and this is accompanied by very low temperatures, as you can see in the images, and also this is opposite during the northeast monsoon season. So we tried to link these biophysical parameters with the mackerel fish catch. And here we can see in the first graph where we have like a similar trend between chlorophyll A and the mackerel fish catch. And it showed a very positive correlation and at 1 month lag, meaning that chlorophyll A or phytoplankton biomass peaked a month earlier and then followed by the mackerel catch. And then we saw an obvious opposite relationship between sea surface temperature and chlorophyll A. And so these relationships were retained for during the interannual variability. And also we wanted to see what causes the enhanced productivity in the Pemba Channel. So we looked into the upper mixing, in which we were able to understand that it has a significant impact on the phytoplankton blooming, especially when it peaks during the southeast monsoon season. So this was also confirmed by the anomalies and the cumulative sums that were displayed, that displayed a very strong positive relationship. So in conclusion, this study was able to show that we have strong relationship between both chlorophyll A and the SST, and then that the upper mixing might be one of the biggest influence of phytoplankton productivity, at least locally in the Eastern Pemba Channel. I think that is it. Thank you.
Thank you, Ellen. I hope you hear the clap. So thank you very much. Any question for Ellen? Yes, one.
Hi, Ellen. Thank you very much. Very nice work. I just wanted to ask if we nest a higher resolution model into your Copernicus larger scale model, what would be the information that would be adding? Are we adding information here? Do you need a resolution, more resolution? What is the missing part in the 1/12 of a degree model?
Yeah, so thank you very much. So the thing is the data that we used, and especially for the area that I was using, the resolution is actually very low because the area is highly influenced by other components. So like having higher resolution data could be more effective in showing more clearly like what we have in terms maybe of phytoplankton biomass and everything. So I think it would be like really good to have a higher resolution compared to the ones that we used.
Thank you.
Yeah.
Thank you, Ellen, again, very nice. We move to the next presentation by Juliette Hermé from South Africa Environmental Observation Network. It's in person. Here, Juliette. And Juliette will present developing a coastal observation lab in a box. So we are moving.
while Nadia's helping out put the presentation up, I'll probably just start in the interest of time. Yeah. So I really wanted to start today talking about CoLab, which is Coastal Observing Lab in a Box. Thank you. So I thought I would start with just a little bit of a story, a little bit of a history. And I feel like if we had a nice fireplace and a good bottle of wine, it would really take me to where CoLab started. Because as all good stories, it really started with a couple of friends, some nice wine, and some great conversations. It was just after COVID, I think, one of the very first meetings I went to. It was an Indian Ocean meeting, and I was chatting with Greg Cowie from the University of Edinburgh. And any of you have met Greg, he can talk a lot. And he was talking about all the field work that he's been doing. So he was telling me that he'd been with his students to Mexico, looking at contaminated groundwaters and reef pelts. He'd been to Honduras, looking at human impacts on mangroves. And he'd been to Jamaica, looking at groundwater nutrient contamination. And, you know, I was like, oh, Greg, I really want your job now. And he was explaining to me about how he'd been doing all of this with students and just a few crates of equipment. And he hadn't needed specialized labs, and he'd been doing it off kayaks. And I got really interested because we were looking at doing something similar in Africa, particularly in East Africa. So we started talking about how he developed it and, you know, really whether we could copy it and kind of make it more formal and try and do it more in East Africa. And then we were joined, it was an Indian Ocean meeting, and we were joined by another good colleague called Satya Prakash. And I would just take a moment. Satya was sadly taken from us due to COVID, but he had been a real founding member of the CoLab idea. They were doing something similar in India, but because they had more funding, they'd extended it with these moorings. So they were doing this kind of basic coastal observing, but extending it with moorings and with remote sensing. So we were like, well, we want to do something like that. And then if you've got more funding, we'll make it modular so you can expand on it, but you don't have to have more funding. It was about this point that I emailed Nadia and said, you know, does this something that resonates with Coast Predict? And she was incredibly enthusiastic. So that really gave us impetus to keep going. And at the same time, Lucy Kokomo from IFOMA had written to the Goose IOD Ocean Best Practices group because she had been to a workshop with them and wanted to start a task team on coastal observations in under-resourced countries and in putting together best practices. Now, I'm on the steering committee of Ocean Best Practices. So when I saw this, I was super excited because that really fitted in with how we were trying to formalize exactly what Greg and I were trying to do, because you need to get those SOPs as part of your system. And also at the same time, the Commonwealth Blue Charter I was at, and I'd spoken a little bit about what we were trying to do with CoLab. And the Canadians who lead the Commonwealth Blue Charter for Ocean Observation Action Group had started put together this global eutrophication monitoring, or GEM in a Box. And so they approached me to talk more about how we could align. And so their idea with the GEM in the Box is to create a cost-efficient kit for worldwide monitoring. And you can see, you know, there was definitely resonance with what we were trying to do. So they'd learned a lot from GOA on in a Box. And you can see here, they want to, at the bottom there, create standardized global scale data sets. They want to increase data collection and reduce the cost of training. So it was all very much in line with what we were doing. Coincidentally, then I was at a meeting with Jerome Ocon from the Pacific. And he spoke to me about what they were trying to do with their Ocean Acidification Center. So they're doing great work. Again, it relies on GOA on in a Box. It's about training. It's about understanding regional needs. It's about supporting ongoing activities. So again, we were very much, let's learn from each other. And that's where, this is where my first slide starts now. So that's the story. And I think for me, a lot of that just really shows how important these actual in-person meetings are, because it really lets you sit together and throw around ideas. So CoLab, Coastal Observing Lab in a Box, is what we're trying to put together, along with this task team for looking at standard operating procedures. And I've put there an African proverb: if you want to go fast, go alone. If you want to go far, go together. So in terms of CoLab, we're not trying to be everything. What we're trying to be is a place for people to share ideas, to learn from each other's mistakes, to try and formalize things. And if it works that we do it all as a team and that makes us stronger, then that's fantastic. So you can see here, this is our core group of people that we're working with. And so what are we trying to do? We're trying to put together packets of instruments and methods for physical, biological, and biogeochemical observations. So very much an old school approach, affordable, low maintenance, but proven and a known accuracy. So modular, as I spoke about, it can be open source or commercial, sampling gear, field lab, instruments, sensors, and moorings. Minimal infrastructure, that's very, very important. Portable and easily taught with training that can be done in person, online. Diverse applications, so from wetlands to shelf edge. The reason behind this is we want the packages to be co-designed with the region for the region, so that they're really fit for purpose. So the idea is to have a setup and a suite of instruments, low-cost instruments, but then engaging with each region as to what they want to observe and to what will help them. So we're not just going with 3 boxes saying, here, monitor SST and salinity because that's what we think. We're going and saying, these are our suites of observing equipment. What is going to benefit you? We want to be able to complementary to moored systems and remote sensing. So if additional funding is found, we can then really expand. Protocols, as I mentioned, that's really a key to ensuring that the program can be global. And then I'll talk briefly also about modeling and data packages with the end user in mind, and also sort of promoting regional hubs for instruments and sensor cross-calibration, so that people in Africa don't always have to send their sensors off to America or Europe, because the supply chain for doing that is a nightmare, and it means sensors aren't getting calibrated correctly. So vessels, shouldn't need a vessel. Kayak, outboard motors, small research vessels. If there's a full research vessel available, then we can look at expanding. But the key is to be able to do it off vessels, boats, which are going to be available. Basic hydrographic equipment, and there's no particular make or model that we're pushing, but just again, that sort of known accuracy so that we can try and keep things similar globally. In terms of the biogeochemical analysis, there's an array of different instruments that we're looking at, but what's important is that no formal lab is required to do any of the analysis, just the sinks and power and bench space, and also that the equipment's portable, so that, you know, ultimately we would hope to set regions up with the equipment they need, but so that it can also be moved around the coast quite easily. So one of the things that we were able to do in 2022 was to try and do a pilot of the concept. So we held a regional training workshop in Mozambique and online, looking at the Arabian, Persian Gulf and Sea of Oman and the Western Indian Ocean. And we got together a group of people doing coastal observations. And we did some sort of hands-on stuff, but also looked at the concept of CoLab and how they felt it would work for them. And one of the things that people really wanted to know was, how can we access the equipment and how can we get the training? And we didn't really have answers for that at the moment, because we're working off what Greg was doing with his students and looking at what equipment we can get, but the funding to actually set up some pilots wasn't there. But it got us to expand our group a little bit more. And we got a relationship with Dr. Andrew Teller from the US, who leads oceanography for everyone. And he's the founder and lead developer of the OpenCTD project, which is one of the more expensive pieces of equipment. So he's on board, and that's one of the pieces of equipment that we're trying to now develop as part of the package. Also then, we got in touch with Professor Lon Porter from the US, who's an open source analytical instrument developer, and who prints everything off 3D printing. So he can print some of the biogeochemical equipment from his 3D printers, but he's also showing how other people can do that if they get access to 3D printers. So, and then finally, Dr. Bob Bruin from the UK, who's looking and is printing Secchi discs, and he's actually already donated some to the concept, to the project. So what we were really looking at is how we can use innovation to create these low-cost sensors. And so we're still in the phase whereby we're trying to organize these packages. We're trying to understand which are the key EOVs that we can put together a suite of packages for, and which instruments, and what the costing is of this. But of course, you know, we wanted this to be a whole sort of fit for purpose complete value chain project. So we wanted to consider how we're going to deal with the data. How are people going to upload their data? How is it going to be global? And we're lucky enough to be working with Kevin O'Brien on this, who does all of the sort of more supports the Goose Observation Coordination Group offshore ocean data, and the ERDAP service, which is obviously very well established now. And he's put together some ideas for us to work with the data, bearing in mind we're going to be working with people who maybe don't have a lot of internet access, who are maybe working with cell phones. So how can we do this in the best way, least data intensive way possible, make it globally available, make it available just to them, ensure that it's flagged if they don't want it to be available. So we're lucky to have the support of Kevin and Noah to work with that. We also wanted to look at the integration of ocean models in two ways, really. One, in a way that we can help develop capacity in ocean modeling if there is that capacity in the country and the desire to do that. And so we were looking at what's being done in South Africa, and Nkululeko is going to talk about that tomorrow. So I'm not going to talk so much about that today. But the other is where there's maybe not the capacity to run ocean models. And so how can we do this on cloud-based systems? How can we give access to ocean models? And also, how can we use the data that we're gathering to evaluate the coastal models? So how can that link happen? And at the moment, we're working with Emmanuel Hunnert from Belgium, who has CLAB, the coastal modeling in the cloud, which is very high resolution and can be co-located. But I think there are other programs doing this. And again, it's a case of, you know, how can we work together to improve what we're trying to do? So what have we done? What's next, and where does Coastal Predict fit in, or Predict on Time? So we held a number of workshops in 2022 to really get out there and to talk to stakeholders and try and understand whether this would be well received and what we need to do. I mean, basically, we're just a bunch of people that drank some wine together and came up with some ideas, and it grew, and we really want to formalize it. So we've been submitting some proposals. We want to get the main team together so that we can finalize everything, but we also want to get some pilots regions, some pilot studies, so some funding to do that. We want to finalize the EOVs that I talked about. So let's get a suite of EOVs that can be adjusted depending on what you want. The data management and modeling tools, we also are looking at finalizing that, training plans and teams. Quite importantly is a business model. A bunch of scientists putting together a business model is quite a tricky thing to do. The current best practices that are available, that's being worked on by the task team. And then to follow up on the training, we've been successful with one application to the Commonwealth, and then also to host a meeting in Brest. So that's great. And then the regional training camps, we have 3 where we'd like to roll it out. And so that's where we're really looking to get the funding. And then kind of where does Coast Predict and Predict on Time fit in? Well, pretty much on all of those. We want to use the expertise that's in the group. We want to see some of the projects that have been presented and that are going to be presented. How can we integrate them or support them? How can the innovation, how can Predict on Time help us with that? And also with the modeling and the data. So I'm super excited to hear more about this and to talk to everyone and try and get more people on board. So I just want to finish up by highlighting one of the proposed regional training camps for CoLab. And we have put in Ghana, our colleague in Ghana has put in a funding application for this. Basically, Ghana is the 2nd largest gold producer in Africa. And this artisanal and small-scale gold mining, or ASGM, severely affects large rivers in the Western region. And they think by 2030 that fresh water in Ghana really is going to be a serious problem. It's not well regulated, and so it puts sediments and pollutants such as mercury into the water. And you can see there the difference between a couple of the main rivers in Ghana. And that's only over, well, since 2009, but that change has been more recent. So what we want to do through this proposal is to use those 2 river estuaries as study sites and as a CoLab regional camp. Ghana is well established. We know Brian works there and other people. So it's a great hub, and it will be supported by the country because that's really a key key aspect of this is that we have to have country buy-in and we have to have in-country co-funding. I don't feel that it will be successful or sustainable if we go with external funding and don't have buy-in funding from the country where we're hosting the regional camps. And that's why Ghana for us is really where we want to go first, because they're trying to put together funding to do this. We also, on the right there, we have a low-cost technologies and data workshop that's happening in June. So anyone interested in that can just register. I'm sure if you want to do a talk, there's probably still time to do that. But what I wanted to finish up with really is this quote by Nelson Mandela: "What counts in life is not the mere fact that we have lived. It is what difference we have made to the lives of others that will determine the significance of the life we lead." And for me, you know, you could really change that with observing systems. So just the fact that we've taken some observations, it doesn't count. The only thing that counts is what difference those observations make. And I know we talk about co-design a lot. I think everyone probably has co-design in their presentation, but how seriously are we taking it? How many members of the socioeconomic community are kind of at this workshop? But not just that, the next level, how many members of the community themselves come to the workshops? So in South Africa at the moment, it's become very important that we have a lot of artisanal fishing, subsistence fishing. And so when we have meetings discussing coastal observations, you know, can we get a representative from that community to be part of the meeting? It's difficult. It's a different language. In South Africa, it is a different language. You know, they're mostly speaking, well, Afrikaans on the West Coast or Xhosa on the East Coast. But, you know, to really make a difference, we have to engage and we have to try. So that's me. Sorry, 16 minutes.
Congratulations, Juliet. Very, very interesting. There is one question there. Sure.
Well, firstly, that's really cool. I love it. So my question is kind of asking where you think marine autonomy might fit in. Clearly not low cost and easy to use out of the box, but I mean, it's an expanding field of how to observe. So I'd be interested to hear what you think.
That was one of the questions we also had at the Mozambique workshop, and we were fortunate there to have some gliders as part of the workshop. So I agree that autonomous vehicles should always be part of this, but it should be, that's why we're taking that modular approach, right? So that if you get the funding for a glider and you have the capacity to run it and analyze the data, then you can bring that in. Or, you know, your data and the work you're doing can enhance international glider projects that want to come and do work in the region. I'm using gliders as an example, but also looking at innovation as to how we can make autonomous measurements more low cost as well. So developing in-house gliders and drifters. Thank you.
I just have a comment. I think Colab fit perfectly in Predict on Time, and also for sure long-term observation for plane. There is there are several collaborations that I see. One is creating a network of citizen science or community science and sensing. So you'll meet Marco Marcelli here, later he will present, and of course there are other also experience already in Predict on Time, like Costa Snap. So I think we need really to end the smart sea level sensor in Savannah. And the other component, very exciting, is how to integrate the model. So the relocatable modeling system, it's already in the objective of Predict on Time. And I think you mentioned the Belgian experience. We have SURF experience by University of Bologna and CMCC and others already in the project. So I think it will